Start the recording. And once again, the message, the following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo, the most exciting channel out there. Not. Okay, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. Alrighty, so today we're reviewing for the upcoming test tomorrow. So questions from the last section of chapter 6 as well as the chapter review. That's what we're going to do today. You have questions? I'll get you answers. Alrighty, so whoever wants to go first, bring it on. Don't be bashful.
So I think it was question number 5 on the review. It
Right.
wasn't really a problem, but it was like a fill-in answer, and I didn't know what it was.
Okay, do you want me to pull yours up specifically, or do you want to just tell me what it is, or what do you want to do?
You can pull mine up. I got it wrong.
You don't mind that everybody sees that?
No, I don't care.
Since you've basically just said it anyway, right?
Yeah.
Yeah, okay. All right, so let me go ahead and get into WebAssign.
I haven't finished it, but it was question 5, I think.
All right, just give me a minute here. Okay. So, and was it Daniela? Was it asking?
Yeah.
Okay, all right, let's see, here we go, there's that. And this is from the chapter 6 review.
Yeah.
Okay. And which problem was it?
I think it was 5, because it was like a 3-part to it.
Okay. So this is the chapter review. I can't talk.
Is that then maybe it was the other part.
6.8?
I think. I don't know.
Okay. All right, well, let's take a look. Okay. Ah, yes. Here we go.
Yeah, for that one.
Okay, you betcha. Let's talk about that. Okay. By X and
I was just confused what the whole thing was asking.
okay. Let's just talk about integers in general. So now can you see my scribbling screen there?
Yeah.
All right, so first of all, what are integers? Integers are like 0, 1, 2, 3, 4, 5, etc. And then -1, -2, etc., etc. So those are integers, right?
Yes.
Okay. Integers, consecutive integers are 1 apart. So like -2, -1, 0, 1, 2, 3, 4. Those would be consecutive integers. So let's say I have the first integer and I call that x. So then the second consecutive integer, there's my lovely abbreviations, would be x plus 1 because it would increase by 1. And the next one after that would be x plus 2. And the next one after that would be x plus 3. Does that make sense?
Yes.
Let's go the other direction. If the first integer is x, what would the one that came before it be? It'd be x minus 1. So consecutive integers, you're adding 1 to each consecutive integer. All right?
Okay.
All right, now, let's see. We'll go -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, 6. Let's talk about consecutive even integers. How far apart are those?
Every 2 numbers?
2, right. So let's say that that was our first consecutive integer, -2. How would we label the next consecutive integer? It would be x
Plus 2.
plus 2. And the next one would be x plus 4, and the next one would be x plus 6, etc., etc. So even integers are 2 apart. So if you start with some unknown even integer and you call it x, the next one, the next consecutive even integer would be x plus 2, then x plus 4, etc. Okay?
Yes, thank you.
All right. Oh, we're not done. Let's say we've got -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5. Let's look at consecutive odd integers. How far apart are consecutive odd integers?
2.
2. So if I call this one x, what would the next one be? X
Plus 2.
plus 2, right? Because consecutive odd integers are 2 apart. Now, this tends to bother people. They go, well, wait a minute. How can x plus 2 represent an odd integer? But if you pick an odd integer and you add 2, don't you get another odd integer? So if this is an odd integer, so is that?
Yes.
Okay, now let's go back and let's look at the problem on WebAssign. So consecutive integers can be represented by x, and the next one would be x plus 1, okay, because you're going up by ones. Consecutive odd integers can be represented by x and x plus 2, because you're going up by 2s. Consecutive even integers can be represented by x and x plus 2, because again, you're going up by 2s. All righty? Does that make sense?
Yes, thank you.
You're welcome. Who's next?
If no one goes, I'll go. I have 3 questions that I would like you to go over.
All righty.
So first being number 18. And if not, I have it written down.
Okay, what is it? Hang on,
It's
wait a second, wait a second. I don't remember which screen I've got showing, so, okay, go ahead.
Okay, so it is -8x squared y minus 8x cubed plus 48xy squared. And it's to factor.
So have I got it copied correctly there?
Yes, from what I recall, yes.
Okay, and go ahead, you said, and it says to factor?
It just said factor.
Factor, okay. So it's a trinomial, and I'm noticing that all 3 terms have x in them. So there's probably a greatest common factor I can take out, but also I'm going to put it in standard form in terms of x. So I'm going to write the term with x cubed, followed by the term with x squared, followed by the term with x. Okay? So there's standard form of this trinomial in terms of x. Now, greatest common factor, I think 8 goes into 48, it does, but my leading term is negative, so I want to factor out a negative. So I'm going to take out a -8 and an x. So that would be my greatest common factor. Any questions there?
No.
So now my leftovers are x squared, let's see, plus xy minus 6y squared. And I'm going to double check that. Let's see. -8x cubed minus 8x squared y plus 68xy squared. Okay, moving on. I now have a trinomial with a leading coefficient of a 1, and it's not a perfect square trinomial. So I'm going to have an x and an x. I'm going to have y's at the end. My product is going to be -6, and my sum is going to be 1 from right there. So how about 3 and -2? So that should be the answer. And again, those last two factors could be commuted. So it could be an x minus 2y followed by an x plus 3y. We okay with this?
Yes.
All right. Anybody else before we go on? Okay with this problem? Everybody? Next one, what do you got?
If anybody doesn't have a question, I have another
Right.
one.
Just go,
With
we'll do yours. We'll do the
29.
next person.
Okay. 29, which is, the problem is 9s
S?
squared t plus 9s squared u squared.
U squared?
Uh-huh.
Like that?
Yes. And then plus 9t v plus 9u squared v. And it
Ah,
just said factor.
what's that?
It just said factor.
Okay, so 4 terms. What are you thinking with 4 terms? What comes to mind?
Factor by grouping.
Bingo. All right, but I also see that, I mean, every single term had a 9 in it. So greatest common factor, I believe, is a 9. So I'm going to take that out first. Okay, now, let's see. Maybe, yeah, I think it'll factor by grouping in the order that it is right now. So let's draw a line there. We're going to get 9. And I'm going to switch over to my red pen here. So what's the greatest common factor of those 2 terms? It would be s squared, and my leftovers t plus u squared.
Yes.
So if this is going to work, what are my leftovers going to have to be over here?
T plus u squared.
Correct. Now, what am I going to have to put out here to make this thing work?
Variable v.
And what else?
A positive sign?
There you go. Does that work? Yeah, that gives me
Yes.
plus TV plus V or U squared V. Okay, so now I've got 9 times T plus U squared times S squared plus V. And there you have it.
Thank you.
And I believe you had another one. Before we go on though, anybody any questions on this one? All right, what's next?
So number 41, which was 8p cubed
P cubed.
equals 8p parentheses p plus 2.
So like that?
Yes.
Okay. So I want to get this thing in standard form. Everything on one side set equal to 0. The first thing I'm going to do is distribute the 8p on the right side. Okay. Now, my highest powered term is 8p cubed. It has a positive coefficient, so I'm going to leave it on the left side where it is to remain positive, and I'm going to move everything else to the left side. So I'm going to subtract 8p squared, and I'm going to subtract 16p. So that gives me 8p cubed minus 8p squared minus 16p equals 0. Okay, so polynomial on the left in descending powers set equal to 0. It's a trinomial. It has a greatest common factor of 8p. So the leftovers are going to be p squared minus p minus 2. I'll double check that. 8p cubed minus 8p squared minus 16p. Okay. And that's going to factor into a p and a P. Let's see, you need a product that's -2 and a sum that's -1. How about -2 and 1? Okay. So there it is, completely factored. Now, the directions, what did they say? Just solve?
I didn't write it down,
Okay.
but I'm assuming.
Yeah,
That's
it probably said solve or solve by factoring or solve the equation. So now I'm going to take each factor that contains a variable and set it equal to 0. So I'm going to get 8p equals 0, p minus 2 equals 0, p plus 1 equals 0. If 8p equals 0, dividing both sides by 8, p equals 0. If p minus 2 equals 0, adding 2 to both sides, p equals 2. And if p plus 1 equals 0, subtract 1 from both sides, p equals -1. So, third degree equation, 3 solutions. Do you want me to plug those in and check my work or not? It's up to you.
I'm fine, thank you.
All righty. Any other questions from you?
No.
All right. Who's next? Anybody? Well, this is just for your reviewing. If you don't have any other questions, we'll just end the session. It's up to you. If you want to look at things, let me know. Otherwise, we'll call it quits for the day.
Do you mind going over one more? I don't have like one
No.
on hand, but
I don't mind at all. That's what they pay me the big bucks for, is to stand here and just do all this. All you betcha. What do you got?
I don't have like a problem, but like a word problem involving a triangle.
Word problem involving a triangle. How?
I understand it when you do it, like when I see it, but then when it comes to me at home doing it, I forget. So if I could get another word problem, that would be great.
Okay, let me see what I can find here. Hang on just a second. Let's see. Chapter review. Okay, problem involving a triangle. Come on, I know you're in here somewhere. Huh, here we go. Yeah. All right. So. Let's take a look at number 42. Can you see what is that? It's a crane, kind of caterpillar crane thing with a triangle in its on its hook there or whatever. Is that what everybody's seeing?
Yes.
Yes. Okay. Just want to make sure I got the right screen up. The face of the triangular concrete panel shown has an area of 6 square meters, and its base is 2 meters longer than twice its height. Find the length of the base. All right, so we've got a triangle. Let's see, that's H. I'm gonna switch back to my working screen here. Okay, so here's my lovely drawing of the triangle. It says the face of the triangular concrete panel shown has an area of 6 square meters. So the area equals 6 square meters. Its base is 2 meters longer than twice its height. Okay. Let's call the height X. Okay. The base is 2 meters longer than twice its height. So the base is 2 meters longer than twice its height. So if the height is X, the base is 2X plus 2. 2 meters longer than twice its height. Is everybody okay with that?
Yes. Yes.
All right. We are to find the length of the base. Now, the formula for the area of a triangle is A equals 1/2 the base times the height. So using the 6 square meters for the area, 6 equals 1/2 times the base, which is 2x plus 2 times the height, which is x. Now, yesterday, when I did problems like this, the first thing I did was to clear out the fraction. And I can do that, though in this particular problem, I don't need to if I don't want to, because can you see that if I distribute the 1/2 to the 2x plus 2, the 1/2 and the 2x will reduce out nicely, the 1/2 and the 2 will reduce out nicely. You see that?
Yes. Could you do both ways so I can see it?
Sure.
Or would it matter if you did times 2 to the 6 times 2 to the 1/2, or?
Let's multiply both sides by 2. Let's do it that way. And then if you want me to go back and do it the way I suggested, we'll come back and do that, okay? So multiply both sides by 2, okay? So far, so good?
Yes.
So 12 equals, what's 2 times 1/2?
1.
So now I've got 1 times this times that, but 1 times that is just that times that, which is going to be 2x squared plus 2x. So 12 equals 2x squared plus 2x. You okay with that?
Yes.
Now, this is a second degree equation, so my strategy is to set it equal to 0. My leading term is going to be 2x squared. It's on the right side of the equation. I'm going to leave it there, so I'm going to subtract 12 from both sides and get 0 equals 2x squared plus 2x minus 12. Now I'm ready to factor it. Oh, I can take a 2 out. There's that 2 that we used up here, okay? So if I hadn't multiplied it by the 2, I wouldn't have that, but it doesn't matter, it's fine. Okay, so now I'm going to have 0 equals 2 times x, and I've got to have a product that's -6 and a sum that's 1, so 3 and -2. So 0 equals 2 times x plus 3 times x minus 2. Again, I can divide both sides by 2, or I can just say take each factor that contains a variable, set it equal to 0, and solve it. So subtracting 3, x equals -3, adding 2, x equals 2. But once again, we're looking for positive distance values. So x equals -3 is not good. X is 2, so the height is 2. The base is 2 times 2 is 4, plus 2 is 6. And we were talking square meters for the area, so meters for the height and the base. And the question said, find the length of the base. So the base is 6 meters. Are you all right with that?
Yes.
Okay. Anybody else, any questions on this problem before we go back and do another one? Okay. Let's go back and do problem 43. A circus performer intends to walk on a taut cable, in other words, a tight cable, shown in the illustration to perform at the top of a pole. How high above the ground is the platform? So again, we've got this triangle, and it's a right triangle. Now, it says assume A equals 9 and B equals 7. So the height would be x meters. The base would be x plus b, but b is 7, so that's going to be x plus 7 meters. And the diagonal where the circus performer is walking up, x plus a is 9, so x plus 9 meters. And we're supposed to find how high above the ground. So here's our triangle, okay? So in this problem, it's not involving the area. We want the length of the sides. So we're going to use a squared plus b squared equals c squared. Which of those 3 sides is c?
X plus 9 and then M.
Right, and the M's is for the meters, the units. We don't,
Oh, yeah.
So, okay. So does it matter which side is A and which side is B after this?
No.
Okay, so I'm going to let that be A and this be B. So A squared is X squared. B squared is X plus 7, the quantity squared, equals C squared is X plus 9, the quantity squared. Are we okay with that?
Yes.
Yeah.
All right. So now we've got X squared plus X plus 7 times X plus 7 equals X plus 9 times X plus 9. Foiling, we get X squared plus X squared plus 7X plus 7X plus 49 equals X squared plus 9X plus 9X plus 81. A very common mistake is people take something like X plus 7 squared and they write X squared plus 7 squared, and that's not true. Okay. We all right with that? Combining like terms, 2X squared plus 14X plus 49 equals X squared plus 18X plus 81. I want my leading term to be positive. I have 2X squared on the left and 1X squared on the right. So if I move everything to the left, I'll still have a positive X squared. So consequently, I'm going to subtract X squared from both sides, subtract 18X from both sides, subtract 81 from both sides. On the left side of the equation, I get X squared minus 4X minus, oh, let's see, 32. Is that right? So yeah, equals 0. So now I finally got my equation. X squared minus 4X minus 32 equals 0. I'm going to factor it. I'm going to have an X and an X and a -8 and a +4. That would give me a -32 product and a -4 as a sum. Take each factor that contains a variable and set it equal to 0. X minus 8 equals 0. X plus 4 equals 0. Add 8 to both sides. X equals 8. Subtract 4 from both sides. X equals -4. We're looking at distances, so -4 isn't going to cut it. And let's see, we're supposed to find how high above the ground. So basically, we're looking for X, which is 8, so it'd be 8 meters. Okay. Now, it didn't ask, but what would the lengths of the other sides be? The base would be what, 15 meters, and that diagonal would be 17 meters. Okay. Let's check our work. What's 15 squared plus 8 squared? Does that equal 17 squared? Well, that's 225 plus 64. Is that 289? Yep, it is, so it checks. So 8 meters. All right, let's see. Is that good enough there, or do you want some more, or what?
I'm
Yeah,
fine with this too.
I
Go
have
ahead.
another question.
Yes.
On 6.8, it was question 11.
Do you
You have to read
know
it.
what it is?
It's like a word problem.
Okay. Do you want me to find your specific one, or what do you want me to do?
I can read it to you if you want.
Okay, sure.
So it says a catcher's and a pitcher's uniform numbers are consecutive integers whose product is 132. If the catcher's was a smaller number, determine the uniform number of each player.
Okay, can you see my board? Have I got it showing? Or do I
Yeah.
have to? Yeah, okay. Read it to me one more time, please.
Okay. A catcher's and a pitcher's uniform numbers are consecutive integers.
Okay, stop. So they're consecutive integers, so how far apart are they? 2 or 1?
1.
Good, okay, go on.
Whose product is 132. And
Okay.
then if the catcher's was the smaller number,
Hey, stop. Sorry. So the catcher's is a smaller, so that's going to be X. The pitcher's is going to be the next consecutive, so X plus 1. Everybody okay with that?
yes.
Now, the other thing they told us, they said the product was it 32?
132.
132. And then we're to find what?
Determine the uniform number of each player.
Each player. Okay. So we've got a catcher and a pitcher. The catcher has the smaller number. They're consecutive integers, so that's where we get the catcher is X and the pitcher is X plus 1. Their product, so X times X plus 1 equals 132. Any questions about what I've got written there before we go on? And sorry, I kept interrupting you. I just wanted to get the little pieces as we go.
Oh, it's fine.
All right, so now we've got X squared plus X equals 132. X squared is my leading term, and I want that leading term to have a positive coefficient. So I'm going to leave it alone, and I'm going to subtract the 132 from both sides. And then I'm going to factor it. Let's see, I need a product that's negative 132 and a sum that's 1. Okay, now consider this. If the product is negative, I've got to have a positive number and a negative number, right?
Yes.
If the sum is positive, the positive number has to be more powerful than the negative number, okay? But how much more powerful? Just 1. So it's like 8 and negative 7, or 10 and negative 9, or 20 and negative 19. So those two numbers, their absolute values are 1 apart. So those two numbers are very close together. Here is what I would do. Take the square root of 132, okay? So this would be a calculator problem. And if I take the square root of 132, I get 11.48-ish, okay? So the square root is close to 11. So my two numbers are going to be close to 11, all right? So let's see, 132. 132 divided by 11. Oh, 11 and 12. 11 times 12 is 132. So I'm going to have a 12 and a negative 11 as my two numbers. Do you see how I did that? Instead of starting at the outside edge, I kind of went into the middle because I said those two numbers have to be just 1 apart but different signs. So if you take the square root of the number, you get to the middle.
Yeah, I saw that.
All right. So now this is going to be X plus 12, X minus 11. So X plus 12 equals 0, X minus 11 equals 0, subtract 12, X equals negative 12, add 11, X equals 11. Now, we're not talking distance. I don't know about you, but I've never seen a team that was so bad that their players had negative numbers on. Well, I mean, actually, I think I have, but they don't put negative numbers on it, right? So even though we're not talking a distance, the numbers on the catchers and the pitchers' uniforms would be positive. So the catcher would be 11 and the pitcher would be 12. All righty?
Okay, thank you.
You're welcome. What else? Anybody? Any questions?
I'm good for now. Thank you.
All righty. So this afternoon, I will be here for my regular office hour from 1:15 to 2:15. Tomorrow, we will not have a regularly scheduled class meeting at 11:30. Basically, you've got until tomorrow night at 11:59 p.m. to finish your Chapter 6 test. Keep in mind that once you open up the test, you have 90 consecutive minutes to finish the test. Also, if you need to, go back and read the file, the attachment that I sent you on testing, okay? So you're supposed to do your own work, no contact with other people from a phone. Don't be looking stuff up on the internet. I trust you, right? So take your test, and I will, if I don't see you this afternoon, I will see you on Monday. And now I will stop the recording.